Alright guys, welcome back to our intro into geometry. So this is all just stuff you need to know before next week when we start our actual unit on geometry. So let's just get started. Know that this video, before we get started, know that this video is more for the notation and the difference between congruence and equality and stuff like that than it is for the actual learning and definitions, because a lot of the stuff you guys are already going to know. I'm more concerned with making sure that you guys know how to write it down and not just say it. So without further ado, let's get right in. So first up is parallel lines. I know that you guys know what parallel lines are. They're lines that are side by side and they have the same distance continuously between them. If they did go on forever, they would never touch. So let's have an example real quick. So if I had point R and point E, S, P, all right, and I were to draw a line that goes through R and S and a line segment between E and P, then these lines are parallel, right? So this distance between these lines is always going to be the same if this one went on forever anyway, and that they would never touch if it did. So that's an important thing. These are parallel lines. Now, more importantly for you guys, because I know you guys know what parallel lines look like, how do you write it down? Because that's what I'm going to ask you guys to do eventually. So we would write down first that this is line RS. And notice that I have the two arrows on either side because it's a line. All right, so we have line RS, and I'm trying to compare it to line segment EP. So I would write line segment EP. Again, notice this does not have the arrows because this is a line segment and that is a line, right? So now how do I say they're parallel? Well, the symbol for parallel is just two vertical bars, right? So this is a sentence now. It's a statement. We're going to get step 2 in a second, but we're going to write a statement, and the statement just says line RS is parallel to line segment EP, and that's how I'd write that. And this is what the video is mostly for. Now, how do I mark that on the diagram, all right? Because maybe after I figure this out, I don't want to just have to look up here every time I remember it and see if that, because there might be more than this on the diagram. Well, I would just put these little arrows like this. So I would put the same number of arrows on each line that is parallel, all right? So if I had a third line out here, then I would put this one arrow on it too, that if it was parallel to these two lines, all right? And the reason I say the same number of arrows is because there might be more than one set of parallel lines in the same diagram, and then you'd have to differentiate. So maybe if I'm parallel to this line, RS, I have just one arrow. But if I was parallel to a different line, then I might have two arrows. And then if I was parallel to even a different line, then I might have three, so on. And that might be confusing right now to think about, but don't worry about it if you don't get that, because we're going to have to address that anyway. But just know for right now, if you see the same number of arrows like this on two different lines, that means that those lines are parallel. And vice versa. If you know that two lines are parallel, then you should mark it like this with these arrows. Now, moving on. Perpendicular lines. Again, I know you guys know what perpendicular lines perpendicular lines look like and what they are. They are lines that intersect at a right angle. I'm more concerned with making sure that you know how to write a statement about it and how to mark it up. All right, so let's say you have this situation right here. You have line AH and line TM, and you're like, that looks really a lot like a right angle here. I should take out my protractor and measure it. All right, you go measure it. You start at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Oh, bang. Right there. It's definitely exactly 90 degrees, which means that this is a right angle. Put the protractor away. So now I know that this line right here, TM, hits this line AH at a right angle, which means that TM is perpendicular to AH. Now, how do I write that? Well, first, AH is a line, so I would write line AH again with two arrows in either direction because this is a line. And then I have this, and this is actually a ray, all right? So MT is a ray, so I would write ray MT with just one arrow. And then the symbol for perpendicular is just an upside down T, all right, like this. Just kind of how this looks. It's just that right there. And that means that these lines intersect at a right angle. And how do I mark that on the diagram? Well, I just put a little box, and you guys probably knew that. This symbol right here means that this is a right angle. All right, that's that. Now, congruent. All right, this is where we get into the nitty-gritty here. Congruent is a complex but also simple, and you'll know what I mean by that in a second, concept. All right, congruent means identical in form. So it's like if you had two different things, but they are identical in form. And I like to use the example of twins. All right, if you had my favorite example is this twins in I can't remember what state it was. I think it was South Carolina, and this woman had named her twins. They spelled it lemon jello and orange jello, but you would pronounce it, or no, I had lemon jello and orange jello, and she pronounced it lamangelo and orangelo. All right, so they're twins. They're two different people, but they are identical in form. They look exactly the same. All right, and then I'll go over what superimposed means in a second. So that means identical in form. So here we have an example, all right? This line, WH, and this line, VU. So if I were to take out my ruler here, and all right, I'm like, okay, this is 10 millimeters, all right? Move my ruler over here. That's also 10 millimeters. Great. So now these are the same length, and I know it. So that means I can say that these lines are congruent. So how do I write that? Well, these are both line segments right now. So I would say line segment WH is congruent to line segment VU, and this right here, this equal sign with the little squiggly above it, is the symbol for congruent. All right, so that just says line segment WH is congruent to line segment VU. Now, let's talk about, and here's how to mark on the diagram real quick. So if I, again, put the same number of tick marks this time, so not arrows or boxes, this is tick marks. So if things are congruent in length, things are the same in length, then this two tick marks on this line and 2 tick marks on this line tell me that this length between V and U and this length between W and H is the same, right? That line is congruent to that line. That's how you mark that in the diagram. Now, let's talk about congruency versus equality. Numbers can be equal to each other. Things like shapes, lines, polygons, and other geometric entities cannot, all right? So I would never say that line segment WH is equal to line segment VU, all right? Like I said, that would be like saying that Orangelo is Lamangelo, and that's not true. They're two different people. They're just identical in form, all right? So instead, what we could say is that WH is equal to VU, not that line segment WH is equal to VU, that WH is equal to VU. And here's the difference. WH refers to the distance between W and H, and the distance is just a number. And we just found out that this is 10 millimeters. So essentially, WH is really just 10 millimeters. So what this really says is 10 millimeters equals 10 millimeters. And those are two numbers, so those can be equal. But we would never say that line segment WH is equal to line segment VU, because they're not the same line. They're two different lines. They just happen to be the same length. So in that case, they're congruent, but they're not equal. And that's the difference. Numbers can be equal. Lines and shapes and polygons and other things cannot be equal. They are congruent if they're identical in form. Now, what does superimposed mean? All right, superimposed literally just means to put on top of. All right, so if I were to take, here's two triangles. If I were to take triangle PWO and move it on top of ELF, then I would just do this. And you can see that when I do that, they become, basically, they look like the same triangle. So they are identical in form. And that means that they are congruent. Right? So how do I write that? Well, I would write triangle ELF is congruent to triangle PWO. Now, to prove this, if I really wanted to do that and I didn't have the ability to just do what I just did and use some cool technology to move this on top of that, there are two ways to think about it. The first one is I could just trace this one and then see if it matches up perfectly with that one. Or To really prove it, I would have to measure each thing. All right, I would have to measure LE, this line segment here, LE, and make sure that it corresponds exactly in length with WP, because these are corresponding parts of these triangles. All right, EF would have to be equal to the length of PO, and WO would have to be equal to the length of LF. And in addition to that, angle L would have to equal, or the measure of angle L would have to equal the measure of angle W. The measure of angle E would have to measure up exactly to the measure of angle P, and same thing for F and O. Angle F would have to be congruent to angle O, right? All 6 of those things would have to be true. All 3 sides and all 3 angles for each triangle would have to equal up to each other. They would have to be congruent, all right? And you might be thinking, Coach Rollins, that's a long process. I don't really want to do that. Well, you're in luck, because later in this unit, I will be teaching you guys how exactly to do that without having to measure all 6 things. But that's the way you need to do it right now. But really, that's just know that if you can put one on top of the other and they are basically exactly the same, if they are identical in form, then you can say that those are congruent. Now, bisector, all right? Bisector is a line that cuts an object into 2 equal parts, all right? So, for instance, I have line BC here, and line BC is being cut in half by line TH. And that's that, all right? This line cuts that line in half. That makes this line the bisector. Now, when it does that, the point exactly where those lines intersect is the midpoint, right? So this midpoint, and you guys actually need a bisector to have a midpoint. Like if line TH wasn't even here, and you had point M here, and point M still was the middle of line BC, that would still be the midpoint. But as it stands, this line does go through that line. So we're going to call this line the bisector, and this is the midpoint. All right? But the midpoint is just the middle point of the line segment. So point M right now, for M for midpoint, is the bisector for line BC. Now, how do you mark this on a diagram? Because we got to mark it, obviously. We have to write a statement about it and mark it. So here's how you mark it, all right? This is the easiest one. So there is no single mark like the other ones had that just means bisector. So what you do instead is you just say, well, line BM, line segment BM, is congruent to line segment MC, and then I mark that. And this lets me know that this same length is on either side of point M, which makes point M the midsection, or the midpoint, which makes TH the bisector, all right? So that's something you're just going to have to know. I might put on a quiz, maybe, I might, hint, I might put on a quiz something like this, where I just put, hey, I put this tick mark and this tick mark, which means that these 2 lines are congruent. And I put a line going through the midpoint, and I just ask you, what would you call this line, and what would you call this point? And you would have to know, this is the bisector, because it splits it in half, and this is the midpoint. And that's just something you should know, because these are congruent. Now, bisectors also apply to angles, all right, because you can split an angle in half. So let's say that I have angle BAR right now, and then I decide I want to split it in half, so I do, and I just put my ray T here, all right? Ray T, or ray AT, splits angle BAR directly in half. And I take my, my protractor out, and I confirm this. So then here's how I'd mark this on the diagram. I'd put 2 little arcs, all right, 1 for each. And then since they both have 1, that tells me that these are congruent, all right? So how I write that is I would write angle BAT is congruent to angle TAR. And then I mark in the diagram with these little arcs. So they have the same number of arcs, which means they're congruent. So I might see another set of congruent angles with 2 arcs somewhere else in the same diagram. And that means that those are congruent as well. But they're not congruent to these. They're congruent to each other. And that's what I mean by the differing numbers of marks, right? So if you have multiple tick marks or multiple arcs or multiple arrows, that means that those things are, congruent or perpendicular, or not perpendicular, congruent or parallel to each other, but not to everything, right? So same number of arcs means that it's the same angle measurement. Now, like I said, that is an angle measurement. So we would never say that angle BAT is equal to angle TAR, but we might say that the measure of angle BAT is equal to the measure of angle TAR, because the measure of angle BAT is just a number, all right? So let's say that BAT is equal to 32 degrees. This angle measure here is 32 degrees. And then TAR is also 32 degrees. Well, 32 equals 32. So when I say M in front of this, that means measure of angle BAT, and that's just a number. But BAT itself is an angle. So we would never say that angles are equal, but we would say that the measure of those angles are equal, because 32 definitely does equal 32. So the measure of BAT is equal to the measure of TAR, but BAT is just congruent to TAR. Now, last thing is perpendicular bisectors. And that just means that you have a line that cuts another line in half at a right angle. It's a very special type of bisector, but don't get too worked up over it, all right? So, like I said, you can see here we have line segment CD and line segment AB, and D happens to be the midpoint of line AB, which means that this line right here is its bisector. And not only is its bisector, but line CD is at a right angle with line AB, so that means that it's also a perpendicular bisector, right? So that's just a line that cuts an object into two equal parts, like this, at a right angle. And that's that simple. Have a good day, guys.